So thank you for joining us for this session on the Bazile groundwater management area. So you'll learn more about where that is here in Nebraska from all of these folks. You met me this morning. I'm Crystal Powers that works at the Water Center. So I'm around to answer questions, but I'm going to quickly hand it over to these excellent folks. If you need CEUs, the sign up is on. We don't have a table, but we've got a chair with the form back there, so make sure you get that signed up. And we will take questions. I'll let these guys fill you in on the process. We're gonna be interactive, so I'm gonna turn it over. Who wants to kick off this group? Go for it.
Go for it. Otherwise, do you want to, should we just introduce ourselves all quick?
Yeah, please do introduce.
Okay. So we are the Bazile groundwater management area. This is a 100% partnership situation. So we're all from 4 different entities working together on this project. So I'm Amy Timmerman. I'm a crops and water educator here in the state of Nebraska, and I serve as the extension liaison on this group.
Dawson Manners, I'm the Water Resources Manager for the Upper Elkhorn Natural Resource District, which is up in northeast Nebraska.
I'm Connie McCarthy, and I'm from the Lower Niobrara NRD office. My office is in Butte, Nebraska, and I am the programs assistant.
Connor Baldwin, I'm the groundwater management area specialist for the Lower Elkhorn NRD in Norfolk, which is right around all of that.
You'll see a map.
Yeah, we
As
got
we
a
go
map.
through, you'll understand. If you're not from Nebraska and don't know Nebraska geography, that's perfectly fine. The map will make sense. So we are team teaching. And so we're just gonna hand off from one person to the next. And we all have our different strengths when it comes to this subject matter. So with that, I believe Jocelyn's starting us.
Okay. Okay, so we are going to start with a little bit of history on the Bazile groundwater management area itself. So originally started back in the 1980s. Due to concerns to rising nitrate levels in both community and domestic wells. So up in the Bazile groundwater management area, as the name might hint at, groundwater is the source of drinking water for everybody in the district, both the communities and the individual private wells. This is just kind of a really short timeline of some of the important dates in the project. Starting in 1989, where it was first identified as what was then called the Bazile Triangle. I have a map of that for you. I just show you a little bit of difference on the next slide here. In 2012, it was officially designated as Bazile Groundwater Management Area. We often call it the BGMA or just the Bazile area for short. Quite a mouthful to say. In 2014, we added a National Water Quality Initiative or NWQI area. And so that allowed for some federal funding that Connor will kind of go through a little bit with NRCS and some funds that became available for practices for producers there. And then in 2016, the Bazile Groundwater Management Group put together and were approved for a plan by the Environmental Protection Agency for 319 grant funding. And that was the first federally recognized groundwater plan approved that was addressing non-point source pollution. This is the original Bazile Triangle. This kind of gives you an idea of where in the state we're kind of talking about. We kind of mentioned northeast Nebraska, a little bit into north central, and then kind of as Amy mentioned, we all kind of work in different locations. And so it has 3 different counties, 4 different NRDs, and we'll look at that here a little bit closer in a minute. So, no, you're good.
You can go.
Okay, so this is what the Bazile groundwater management area looks like today. It is a total of 21 townships, 756 square miles, 800, which is about 883,000 acres, 100,000 acres. There are 10 communities in total of all sizes, some of them are unincorporated, and some of them have their own water systems, and then there's about 7,000 rural residents throughout the area. Ooh. There we go. We'll get there. Okay, so this is a better look at what we're dealing with here. We mentioned the 4 NRDs. So if we gotta go clockwise, we'll start with the Lewis and Clark NRD. They have a small portion up on the top right-hand side that's in part of Knox County, one of the 3 counties. And then Lower Elkhorn, which is where Connor's at, has a large portion both in Knox and Pierce County. Upper Elkhorn has the larger portion. The district boundaries are those blue lines on Antelope County and the southwest part. And then Lower Niobrara has a portion of Knox County, also in the northwest. This map was intentionally picked. I know it's a little hard to see, aerial is a little much, but within the Bazile area, land use is mainly crop ground and a little bit of pasture and rangeland. So 3/4 crop ground for the area that's not included in the communities and 1/4 pasture and rangeland. So this gives you a really good idea where all this is. A lot of that crop ground is irrigated, and that's where a lot of what we have going on here comes in. But there is still dry land, crop ground in there also. This kind of hints to what Amy was mentioning, where this is a lot of agencies put together to work on this project. The original plan was put together by these agencies and then also some additional input from local producers. But right now we have a project as a whole had a Bazile coordinator. We are actually in the middle of coordinators right now, but they're the one who is in charge of a lot of the funding and the projects and interacting with the producers on the local level. We also have a Bazile extension educator, and we are working on getting a new one coming on. We just got a new one hired and in the process of getting them up in our area, hopefully have them soon. And they are a UNL employee that's specifically working with projects in the Bazile area. And then the 4 green bubbles are the 4 NRDs, as mentioned. We have the Lewis and Clark, which is based out of Hartington, the Lower Elkhorn, Lower Niobrara, and the Upper Elkhorn. We have some of our state and federal partners, the Department of Water, Energy and Environment, which was formerly Department of Natural Resources and the Department of Energy and Environment, right? They just changed on us in July, so a lot of new acronyms to learn. And also the Environmental Protection Agency at the federal level, University of Nebraska-Lincoln, and then also Natural Resource Conservation Service with some of the funding and the help with the programming. And then we also have some of the local options. We have some tribal with the Santee Sioux Nation, where the Bazile Creek is, which is how the Bazile Groundwater Management Area was named. It flows towards their area, and so they also interact with our project, the USDA on the federal level, and then also some of our local ag industry partners when we do some of our demo work, which Amy will talk about, and then also the producers just daily, and then also they offer some of their ground for some of those projects. Okay, so we are going to focus on nitrate. Nitrate is the main issue why the project was started, and we're going to go ahead and take a look through history as to the project, the problem itself, and then also incorporated in here, I mentioned that there's a high irrigation area, high cropland area. We're going to look at those irrigation wells and how they were added. We're going to take a decade by decade look at this. So one thing to note, all the nitrate samples that are used in this were collected by staff, like the NRD staff. So this isn't any producer collected samples, it's samples that we have. And that will go by decade. And then we'll have the cumulative irrigation wells. So once the irrigation wells are on there, you will see them again. The nitrate data used per decade will change. Okay, starting in the 1960s. No nitrate data for you. The natural resource districts were formed by the legislature in 1972. And so they didn't exist. So we don't have any data pre-1960. We won't have anything for the 1960s either, but just wanted to give you an idea of the irrigation wells that did exist at that time. Up in the, does this work? Will it work that far? It doesn't reach that far. Up in the top right-hand corner, it does say how many nitrate samples that were taken during this decade and how many wells were drilled during that decade. So that number isn't cumulative, but we'll give you an idea. The legend up in the top left will stay the same, and there's 5 different nitrate ranges for the coloring that you'll see as we go farther forward. So anything blue is less than 5, green 5 to 7.5, and this is parts per million. Yellow 7.5 to 10, and then that health drinking water standard is 10 parts per million. So anything that you see that's orange or red will be above that standard, and orange is 10 to 15, and red is greater than 15. Okay, moving to the 1960s. there's a 135 new wells that were drilled, still no nitrate data, but kind of going back and forth gives you an idea of where we're looking. We go to the 1970s, we see our first nitrate sample. It's a little high, so to represent a decade, it does look really high down there, one sample of 16.8. But we do have 951 wells that were drilled in the 70s. Quite drastic. Most high decade of increased irrigation wells that we had. 1980s, we really first start to see our nitrate samples show up. There are 213 that were taken in this decade. And this kind of explains what I was showing. These are by townships, and I do give you that average just for the sake of something easy to point out. We're going to focus on that 29.5, which right now is in the top row, kind of center. It's yellow right now, 9.4, and the city of Creighton is there. I'm going to specifically pick on the city of Creighton because we'll get mentioned again later. So in the 80s, this is when they were first starting to look at the project, and when the project was first formed. So it kind of gives you an idea of some of the issues that they were having even then. We go forward to the 90s and we're already up to the reds. So sticking with Creighton, it's gone from 9.4 already up to 16. And we have 895 nitrate samples in this decade that were used to collect these. One thing I will note out, because it's the only, this is a great map to do it, it's the only white one. I'd like to point out that top left township, where Wausau, the city of Wausau is. We will come back to that later, but this is just a great map to give you an idea of which one I'm talking about, since it's the only one that didn't have samples that decade. Okay, moving to the 2000s. We have over 3,000 nitrate samples in this decade, another just over 500 irrigation wells that were drilled. And looking at Creighton again, we are up to 18.5. So it did still go up, but we have so much more of the area that is also now above that drinking water standard. We're looking at just 5 townships that are below that 10 parts per million. 2010, we have 2,500, 2,600 samples that were taken, another 413 wells. And I did check this because it was crazy to me. I had to go look. Creighton's township at 28.95 did stay 18.5. And actually, if we look just to the left of that, where that 29.6 is, we go back to the 2000s. It was at 16.2. It's come down to 12.2. So there is some movement both directions. But then you look at the bottom and everything in the upper Elkhorn portion of the Bazile area is above that 10 parts per million. Okay, 2020s. This one is slightly different because we're not done with this decade yet. So there is only 5 years worth of data contributing to this. But at this time, we have over 1,500 samples in the area that the NRDs have collected. And if we're looking at that Creighton area again, it's come down just a little bit more. We're at 16.8, and that 29.6 is also down at 10.6. Across the board, we are still looking at going up. You go back to the 2010s and look down kind of that bottom row, that 27, 3, 4, and 5. They go up there in color, and then also up farther in that upper Elkhorn in the middle of the area also did go up farther. Okay, so we looked at some of the data, we looked at the problem, we know there's a problem, but why is this area so susceptible to nitrate contamination? Just kind of fun to point out the pictures here. This is actually from a demo that we did where they were looking at cover crops. So we got a nice shot down the corn row and looking at some of the cover crops they're going, and Amy will talk some of those demo sites. Okay, gonna look a step farther out than just the irrigation wells. This is all the wells in the Bazile groundwater management area. There are 2,870 irrigation wells that we showed on those maps. There are 561 domestic wells, 285 livestock wells, and I should mention those domestic wells, that's how many we have that are registered. The way that wells are in Nebraska, anything that was drilled prior to September of 1993 for domestic wells doesn't have to be registered, so there could be more out there that we just don't have included in that number. Municipal wells, there are 23, and just other types of wells, as general, there's 417. So just in that small area, we're looking at over 4,000 wells. Okay, back to the irrigation wells. This gives you a nice breakdown on that 2870 number. And kind of really highlights how many wells were drilled in the 70s. You didn't have to get to the 2000 before you see any wells drilled that are close to that number, and that's still half of what was drilled before. But it does make a very impressive bar when you add up together as to how many wells we're actually looking at irrigation wise. Sticking on the irrigation, kind of give you an idea of just where we are geologically and where these wells are screened. So they do range from pre-1962 current day and how they were, and when they were drilled. So you're looking at different types of screening, different types of depth, pretty much different everything. So typically these wells are either screened in the quaternary sands and gravels, the Ogallala formation, or sometimes the screens span the whole well and it goes through both. So I have put on here a geologic framework for you that CSD or Conservation Survey Division for UNL put together. And this kind of gives you the idea of where we're at. We have the sands and gravels, and then this on here, it just has it as the Ogallala group, but the Ogallala formation would be in that general area, give you an idea of where we're looking at. Some more facts about the general area. I mentioned Wausau earlier. There are 3 topographic regions on here. The main reason I pulled out Wausau for you is there are glacial till deposits on that side, and up in the Wausau area, they are less than 150 feet. And because of that, that area is not hydrologically connected where the rest of the Bazile area is. 3 different regions, 3 different ideas here. The plains is where we see a lot of that farming and a lot of that nitrate, just to kind of connect them. A very sandy area. So sandy soils goes along with this quite well, actually. This is the saturated hydrologic conductivity of soil, so how well when saturated, how quickly things can move through the pores. It is very high, it is moderately high, and in some places very high, especially on the south and west sides. So it's very, very quickly moving through, groundwater can move through the area. Groundwater regions, we also have 3 in here. Sandhills is that yellow one, majority of it. A little bit of north central tablelands, and then that blue is glacial. Thank you. Glacial drift. The other thing that we haven't mentioned so far, but it is definitely something we need to talk about, is depth to groundwater. So this is a map showing depth to groundwater from the surface. So the lower the number, the closer to the surface. Over half of the area of the Bazile has a depth to groundwater of less than 100 feet. And pretty much the entire area has groundwater depth of less than 200 feet. So it is a very shallow water table, and it's very easy for nitrate to move through from the surface to the groundwater. Okay, just kind of gonna tie it all back together for you. Reasons that's acceptable. We kind of have a melting pot of everything. We have the right geology, the right hydrology. You got the high water table, you got the really sandy soils, the topography, and then we've also got the economy. The way the whole area is laid out because of those other 3, we're in the right kind of area for all the agriculture that we have to happen. And the one other thing that's really kind of cool, this picture here is actually from the Bazile area. They were digging to install waste emitter equipment, and they took this picture, and it's a great, what's the word? Lost the word.
You're able to see the soil profile change.
Example, yeah, it shows he's even got the corn stalk still on the top there. It shows how definitive it changes from the topsoil into that really sandy soil. There's another picture of them holding each of those, and you can just see how sandy it is from the soil to go from that to the soil. So that one, we're gonna do all questions at the end then, or
We could probably ask questions
I
now.
think Connor's slide. Yeah, that's Connor's slide.
Any questions about
what's questions now? Otherwise, we can just wait till the end also, so. All right, I will let Connor talk about the next portion.
All right. So yeah, you've seen why we have the issues that we do, and you've seen the issues that we have. So I'm gonna go over a few of the things that we're doing to try to combat those issues. It's kind of I'll call it a two-step approach. It's two really big steps, but I'll call it a two-step approach. One step, we have our phases are almost all of the area is in a regulation of a phase one or phase two, phase three area. So there's different implications that goes with that, and I'll go over those in a little bit. The other thing that we're doing is we have what Justin called an NWQI area. And I think she showed that map earlier. No, okay, well, the whole Bazile is been determined by the NRCS as a national water quality initiative. So there's some higher cost share rates in that area that we can piggyback off of, as well as we apply for some grants. I'll go over that too, so. Okay, so this is our map. Like Jocelyn showed you, the entire area, like I mentioned, is the National Water Quality Initiative. Like I mentioned, almost the whole, do I need to use my phone? Or you guys can be fine, okay. Almost the whole area is in a phase 2 or 3 groundwater management area based on the NRDs. There are 4 different NRDs, so we have 4 different sets of.
We're recording.
Oh, okay. I'll use my phone, so. So we have 4 different sets of rules and regulations based upon, you know, what the rules that were set by each NRD. They're all pretty similar, and again, I'll go over those in here in a little bit, but the only portion that currently is not in a phase area is kind of that northeast portion up by Wausau. Just because that area, we haven't seen the high nitrate as much as the rest of the areas, so. And here's where, again, these phase areas, they're all fairly similar per NRD. But each NRD has kind of their own special set of rules and regs. So our phase 1 area, if I go back, I believe the only phase 1 area would be kind of the northeast portion there. So that area is between 0 and 5 parts per million, which again, the safe drinking limit is 10 parts per million set by the EPA. So it's less than 50% of the MCL, so it's been designated a phase 1. And so in that area, we're really just kind of permitting irrigation wells, monitoring continuously to make sure it stays that way. And there is a couple districts that require nitrogen certification throughout their entire districts. And so what that means is the producers have to attend a class that apply nitrogen, I should say. They have to attend a class once every 4 years, get some hours in, and we can certify them in. So I'll go back, phase 2 areas, again, this is where it's gonna kind of start splitting up between NRDs, but most of that light blue up in the top left, and then a little bit on the right here, is our phase 2 areas, which is gonna be between 5 and 9, or 50 to 90% of the MCL nitrate. What we're looking at there is annual crop reporting, and I think it's only corn and soybeans or potatoes of this. There's a little bit of potatoes and portions of the Bazile. Some deep soil testing, so the producers know, you know, what levels of nitrogen they have, so they can take credit for it in their crop reports. Or their crop budgets, I should say, nutrient budgets. Water sampling, both by the NRDs and the producers. Like Justin mentioned, we have a lot of wells that we sample every year, the NRDs do, or every other year. I don't know the total number, that set of Bazile wells, but there's 125 in Lower Elkhorn. I think there's roughly 400 that we try to get to at least every year or every other year. Again, just to kind of keep an eye on those, and that way we kind of have a set data set that we can look at, so it's the same well that's getting sampled multiple times, you know, over the years. But then also the producers have to take water samples, and that's basically just for their information. So again, they know how much nitrogen is in that water that they're applying on their crop fields. So again, they can take credit for that in their nutrient budgets. So kind of, you know, basically trying to make sure they're taking credit for their credits that they have, so they don't have to apply quite as much on the corn. Nutrient fertilizer restrictions. Some of that is, a certain amount, can't apply over a certain amount per application. Like in the lower Elkhorn, you cannot apply more than 50 pounds of nitrogen at a time. There's not a set number of application limit, but there's a set per poundage, at a time. So basically, the point of that is just to try to encourage split application. Because of the sandy soils, it doesn't hold the nitrogen like a heavier soil would. So the more you can split that up, the less leaching we're seeing, so. And nitrogen certification, the other two districts that don't require it in their whole district, this is where that kicks in, like I mentioned, so. And phase 3, so basically the dark area, of the Bazile, so 3/4 of the Bazile is in phase 3 groundwater management area. And that's basically 90+% of the MCL. So as Jocelyn's slides pointed out, there's a lot of areas that are up in the 15s. Well over 9. So again, it's more intense soil sampling. So like in phase 2, sometimes we gotta do it every 4 years or certain crops. Phase 3, they gotta do it every year. Water sampling every year. We also have more advanced nitrogen fertilizer controls. And a couple of districts have a required crop rotation plan, trying to break it up from corn on corn, throwing beans in there, or small grain or something like that, so. That's kind of the approach on the, I guess, I'll call it regulation side, that the entities have put in place. I'll start talking about the grants that we applied for and the funding that we've been able to get in that area, to get special management practices on the ground. Yeah.
What's the advanced fertilizer controls on phase 3?
So, that would be like, requiring, urease inhibitors, nitrification inhibitors. There's a, one of the districts, I'm trying to remember, one of the districts has a more, trying to think.
And they don't know how much they can apply at a time.
Yeah, it's slipping off the top of my head, I'm sorry, I'll have to get back to you on that, but one of the districts has a little bit more advanced control when it comes to applying nitrogen. Well, and I guess the other thing would be, they can only apply between October 15th and March 15th and October 15th, sorry.
Yep.
So basically preventing, non-in-season application, so. It's kind of a hot topic in a few of our areas, because some of the guys say that. The heavier ground can hold it if you apply it in the fall. I still would argue the best time to apply nitrogen is in season, so. It's a hot topic in the area.
No anhydrous applications.
Basically, yeah, that's essentially what that's preventing is anhydrous. Okay. So yes, in 2017. The NRDs applied for a 319 grant from the EPA, and we were awarded, it was the first 319 grant that was awarded for groundwater. Before that, they had just allowed 319 grants for surface water, so we were the first for those, as well as the NRCS, like I mentioned earlier, came up with or designated it as the NWQI area, which basically allows us a special fund pool specifically for that area, to get EQIP practices on the ground. And in 2020, I guess 2020 is when they said that, and then 2023, there was further funding, the Inflation Reduction Act. I'm sure you guys are all aware of those funds NRCS had, so we got further funding from those in 23. I believe that's over now, but it got us a long ways, so. Priority practices, so these are the practices the NRD managers have approved, that we can fund 319 funds on top of the EQIP funds. So basically, NRCS gets these contracts with the producers. They pay the producers the EQIP fund rate, whether it's 50, 65%, whatever it is. We then can put 319 funds on top of those to get up to 75% cost share rate. And then the NRDs throw on another 15% to get up to a 90% cost share rate on these 5 BMPs that we have up here on the board. So no-till practices, crop rotation, so that's like throwing a small green in or something like that. Cover crops, everyone knows what that is, obviously irrigation water management. We're starting to try to get into some of the variable rate stuff. Fortunately, those contracts are really big and really expensive, so they take a lot of funds, but. And then the nutrient management, which is, in my book, nutrient management, irrigation, water management are very important part of the puzzle, so. And cover crops are by far the most popular just because it's the most widely used in the area. People have been doing it for years, so. And I mentioned the 319 funds, the only areas that we have applied for, I would call the dark blue and the light blue, or what we call the tier 1 and tier 2 areas within those communities. That is basically the wellhead protection areas of those communities. The darker blue is a 20-year time of travel for water, and the lighter blue is the 50-year time of travel. So those are the only areas, I guess, that we kick the additional 319 NMD funds on top of, just because the wellhead protection areas are obviously a very important part of trying to keep the communities from having to spend money that I'll talk about here in a little bit. Or right now, I guess. So Creighton, which Jocelyn mentioned earlier, again, has a really high concentration of nitrate. They actually installed the first RO system in Nebraska for the whole town. It's a very expensive project, millions of dollars for a community of 1,100 people. It's tough. They have extremely high water rates for their customers, and it hasn't been a great situation for them. Luckily, they can get the RO plant in place, and it works, but it's extremely expensive to operate for a town of 1,100. So Brunswick, they've had to do a few things, replace some wells and mains. Orchard, they are currently on administrative order, so they are looking at needing to do something. They have one well that keeps coming up at 11 parts per million, so they can't sell water basically out of that well. Osmond, they're kind of right on the verge. They're just under the 10 parts per million right now, so they're not currently on administrative order, but are fairly close. Plainview is currently on administrative order. Again, they are looking at digging 2 new wells for their community south of town and piping it. It's like 10 miles or something like that. So again, very expensive digging 2 new wells and then transferring that water that far. So, and then the domestic wells, again, that's gonna kind of be like what Jocelyn talked about. There's 313 is what it shows, but really the number's a lot higher. There's only 313 that are registered. There's a lot of old domestic wells out there that just haven't been registered, so. And the total cost roughly, with all of those things of over $10 million is what it's cost those small communities. Communities of 1,100 and 360 people, 800 people, it's extremely hard to do. Like treatment plants or digging wells, just because it's so expensive for them. And the impacts of partnerships. So because of the problems we have, the money that's costing the communities, the NWQI area, so the whole Bazile area basically, from 2018, so the start of the project until now, we've been able to help 133 producers get BMPs on the ground. So we've EQIP has thrown in over $5 million specifically for funding those BMPs. 319 has been able to kick in over $1 million extra, and NRDs, and this is just on the EQIP funds, doesn't count anything else NRDs are doing, but NRDs have kicked in another 126,000 on top of EQIP and 319 in those 7 years. So, and it's over 23,000 acres that we've been able to implement BMPs on in that area. So we've made a lot of progress, I would say. Getting BMPs on 22,000 acres is no small task. So it's been a good project. Hopefully we can keep it going. So I'll leave you with this. There's 2 graphs here showing a 10-year and a 20-year. This is the 10-year nitrate trend. So we are starting to see a couple townships, again, kind of right there, Creighton, you can see the blue one, a couple townships are starting to trend downward, which is obviously what we want to see. And this is a per year nitrate trend, so not over the whole 10 years, but a per year trend. So it is encouraging to see, we're starting to see some downward trends in some of those areas that are having such trouble. Unfortunately, we do still have some areas that are trending upwards, so. And the 20-year is a lot of the same, not trending upward quite as much, and then we're actually seeing some stabilizing and some decreasing in some areas as well, so. It's encouraging, over the last 10 to 20 years, it looks like we're starting to make some headway in a few of the areas. Unfortunately, there's a few areas that we haven't, but those will be our target areas for the future, so. That is what I have, if there's any questions.
So you mentioned split application in phase 3 areas, right?
Yes, yep,
Maximum they can apply is 50 pounds in per acre.
yes,
So do you time it, or like, let's say if I apply today 50 pounds, I can apply another 50 pounds tomorrow, or?
yeah,
Yeah.
theoretically you could, yes.
Okay,
Basically what we tell guys is, yes, in that instance, we get that question all the time, and yeah, I could apply 50 pounds today and apply 50 pounds tomorrow. But they're not going to do that just because of feasibility reasons, they're busy enough that. They're not gonna be able to apply 50 pounds, I wanna be able to turn around and do it again tomorrow, so even if they can spread that out a week. Apply 50 pounds this week and 50 pounds next week, like for fumigation or fertigation, for example. That's a lot better than applying 100 pounds in one day,
and how late do they generally go in the season, growing season, to apply, let's say, the last round of the fertilizer?
So basically, the only restriction we have on that is, they just can't apply from March 15th to October 15th. Or that's the only time they can apply, so as long as it's before October 15th, there's no restrictions in terms of when the last application has to be or anything like that.
Connor, you might speak a little, since we have people from other states, speak to the number of staff support, because that's not captured in your numbers of like the
Right.
number of that the NRDs provide and testing and staff time. I know you don't have the number, but just
Yeah.
speak to like that whole infrastructure that's the backbone and the education people. Because to replicate this, it's not just the federal funds, it's like the
Right.
staffing, like you guys and
Yeah.
others.
So I think there's the whole Bazile team, there's almost 50 of us involved in this project, so it's, not a small project, and the Water Institute has been a big partner of ours along with NRDs, NRCS. It's been a huge task, I don't know the numbers specifically, but like I mentioned, those numbers of the NRD funds, it's 126,000 we put on top of equip in 319, but I think we Lower Elkhorn specifically, I think we budgeted $150,000 a year just for the Bazile project, so times 7, I guess, and the other entities, the other 3 would be the exact same, so. There's a lot of money that's been spent and staff time and a lot of time has been spent, so.
So there's probably Jocelyn's right, there's 50 of us, but the core team, there's probably 15 of us that work on this on a weekly basis.
Weekly basis, yeah. Yeah, and our Bazile coordinator, like Jocelyn mentioned, we are currently between coordinators, that's why I'm here, not her actually, but. or them, I should say.
Educators.
And we're between educators. But yeah, the Bazile coordinator, their primary focus is going out, meeting with producers, getting these contracts, getting these applications into the NRCS. So that way, NRCS can take them and work with them and get some BNPs in the ground, so. It's a really good project, like I said, we're starting to see some downward trends and at least some stabilizing of some of the nitrate levels, so. As you can see from like the 1990s to 2000, there was a huge increase, so if we can start, hopefully we're kind of on top of the hill and we can start coming back down now, so. Yeah, and now, yeah. Cool.
Okay, I'll go first. I just have 2 questions. So one, and apologies, maybe I missed this, but like, how do you enforce in terms of like the 50 pounds? Like, how do you handle enforcement, or is it just on an honor system? And then the second question is around, so you're doing some reverse osmosis for drinking water treatment. Just what do you do with that brine that comes out of the reverse osmosis system?
Okay, so I'll go with number one first. So yes, it is on the honor system.
Okay,
So basically they submit those annual crop reports I talked about. We look at that to make sure that they're not applying more than that amount. And the 50 pounds is just in the lower Elkhorn.
It
A few of
varies
the
by
other,
district.
a few of the other districts are a little bit different. Like I said, we all have our own rules and regs that are similar, but not the same, but.
Okay.
But yes, it's on the honor system. We actually in the lower Elkhorn have a phase 4, we haven't had to go to yet, thankfully. Where they will start submitting, like fertilizer receipts and stuff like that. And showing, exactly what they're applying on every field, or right now, they're just turning in reports telling us that that's what they're applying. Number 2, the reverse osmosis systems. So yes, like the city of Creighton has one for the whole city. I believe the discharge system goes into the creek
okay,
that flows,
so we're just putting the brine in the creek.
yeah, pretty much.
Gotcha.
Which is a pretty hot topic, cause.
Yeah.
Yeah, I mean, but what do you do with that much water, for a town that size, so. Yeah, it goes, the good water goes to the town and the bad water goes into the streams, so.
But geologically, it's important to know that that stream, that's the Bazile Creek.
Yep.
It is 100% groundwater fed.
Yep.
So it already has the high nitrates anyway. We might be bumping it up a little bit, but
Sure.
it's already high.
Yeah, we take samples out of the creek and it's pretty darn high already,
Yeah,
so.
got it. And that's going into Missouri. Like,
Yeah, it ends up there, yeah.
Goes in the Niobrara, then to Missouri.
yeah, sure.
You said that you have been able to enroll 23,000 acres in the program. How does that compare to the total, or how much would like to see enrolled, like percentage wise, how that 23,000?
So I forget what the total acre size of the Bazile is.
183.
So 483,000
100,000.
acres, but that's not all crop acres either, so some of that would be, especially kind of up in the northwest portion, there's a little bit more cattle, and even some of the southwestern portion, a lot of pasture down there. So those would be all crop acres, the 483,000 would be all crop acres, so I don't know specifically how many.
6%.
What's
It's
that?
about 6%.
6% of the total area, again, that include streams and towns and roads and pasture, but yeah. So I don't know exactly how many acres of crop ground there is, but we got a long way to go, definitely.
Well, I did Jocelyn's 3/4, so I took 483 3/4,
Okay,
so it's 6% of the crop acres, in a really rough.
okay,
And you have to remember why producers are doing it. Some of them are all about the free money. Some of them don't want to deal with NRCS and all the paperwork associated with it. And then we have another group that says, it's my problem, I caused it, I need to be the solve of it. I don't need the federal government or somebody else fixing my problem, so.
so there are producers out there that are doing these things themselves that we haven't had to throw funding on top of, which is awesome, so. Yeah,
Do you have any data on the value of the crops produced since, pre the 60s? And then the value of, and the amount of crops produced over the decades?
we would, not with us, but yes, we
That's
would,
probably
because
other-
we, like I mentioned, we get all those reports every year from all of our producers. If we pulled it all together, we probably could, come up with a value of what's been produced, total nitrogen, pounds applied, stuff like that. It's a big area, and corn is the predominant crop in that area, so. Anything else? Okay.
All right, I'm gonna change gears a little bit. We're gonna talk more on what the University of Nebraska's been able to offer, working with this team as a full partner. So as they stated earlier, we have a full BGMA coordinator. We're in the transition of getting that person onboarded. I am a county-based educator. And so I spend some of my time in Bazile, but I have, just like my counterparts here, we have other responsibilities too. But the big thing we're gonna first start on is back in 2000, right before COVID hit, of course. We put in a Nebraska Environmental Trust grant between all four NRDs and UNL to be able to do these on-farm demonstration plots. That ended up being more research-based, which was excellent. They are on producer fields, small, small plots, we'll put it that way. Most of the plots were 800 feet long, so that makes them small plots. We had 3 fields. They focused on soil health, nitrogen and water management, and diversified crop rotation. I'm going to share some of the data primarily from the nitrogen and water management location, because that gives us the best data. But before I do that, I do need to talk a little bit about our BMPs. So our best management practices. And one of the biggest components of our BMPs is using what we call the N calculator for UNL. This is our core nitrogen calculator that was developed eons ago. But this is the formula that is suggested by the NRDs and through UNL to determine an estimated amount of nitrogen you're gonna need to raise that crop for the year. So it is now an online system, which is really nice. They're able to put in their field information, they're able to put in the expected value, we're able to throw economics in there. The big thing here is they're gonna put in what their yield goal is. Through nitrogen certification training, we have done a lot of work on what is an anticipated yield goal, what is actually attainable. In this area, we probably are in our annual production history underneath center pivot. We're gonna be anywhere from 220 bushels per acre up to 260 to 280, depending on where we're at. But making sure they're not putting 350 bushels per acre down as their yield goal, because we're not to that point yet. And that's sometimes a hard pill to swallow by some of our guys. We're like, you're not that good yet. We'll get there, but not right now. And we're also not going for the National Corn Growers Association yield award of 600 bushels either. They're also going to be putting in their soil analysis data. Most of the individuals in these areas are required to be collecting those for the NRD, so putting in their nitrate load at 0 to 8, 8 to 12, and 12 to 24 is preferred. They're also going to put in their organic matter, and that's one piece we haven't talked about. Average organic matter in this area, when we look at soils, range anywhere from 0.4% to, on average, the high is about 1.5 to 1.8. So we don't have much water holding capacity at all in these areas, even with some practices that have been done, like no-till cover crops for several years. There are a few outliers where we're getting up to 3%, but the majority were 0.5 to 1.5 in organic matter. We also have them put in the previous crops, so we can get credits there. And then the last big thing for us is how much water are they going to be applying, and then looking at what their nitrate load is in their groundwater. And we want to make sure they are crediting the water that is coming out. Some of the wells are over 15 to 20 parts per million. That's a lot of pounds of nitrogen that is coming out of the ground that they need to take into consideration. And then the last big component, and Connor talked about it, is how are they applying it? And the NRDs in general, and in our word of to all of our producers, is to split apply. So when we're looking at split applications, just to make this a little bit clearer, we're looking at, most of the guys are putting about 50 pounds of N at plant. They're coming in with a side dress application, typically around V3 to V4. Main reason why they're looking at V3 to V4 is to prevent crop stress, because that is when the kernels around is determined on that ear. They will come back in. Typically, they may do a dry spread over the top. Typically, they start a chemigation application on, and if you don't know chemigation, I'll show that on the next slide. They'll come back in about V8 to V9 because that determines ear length. They will then make another application at R1, which is pollination, and then they will make another application typically anywhere from R3 to R5 R3 is when we're in grain fill, so we're really trying to push that plant into filling that kernel. And then some crop consultants in the area do encourage a last application of brown silk. That does not necessarily go into the kernel, but it does go into the stalk, which then impacts our residue carryover, and looking at that whole nitrogen cycle. So if you're not familiar with center pivots, our main form of split application is through chemigation, or we like to call it fertigation. And what we are doing is we're actually pumping chemical directly into the water line that is feeding the pivot. And so with that, we do have a bunch of safety measures that are put in place. Safety equipment that they have 6 pieces of safety equipment they must have. Those wells are also all are registered through the NRD, and they are inspected either every 2 to 4 years, depending on the NRD situation. Now, the big thing to keep in mind is in Nebraska, our Chemigation Act did not occur until 1986. This is when we had regulations start. Jocelyn showed that we had a huge spike in the amount of pivot irrigation that went in the area in the 1970s. The main reason why we saw the spike in the 1970s is that is when center pivots, Lindsay's and Matic really got going, and it became economically favorable for the producers to put them in. Until that time, we had people chemigating, fertigating, but there was no rules and regs associated with it. When you go and talk to the producers and you talk to them, well, they'll tell you that grandfather or great grandfather just poured urea directly down the well and then pumped it out, thinking that, okay, we're gonna pour it down, we're gonna have that cone of depression, it's going to all come back out. Well, it didn't. Now, that isn't the 100% cause of our nitrate issue in the area, but it was a player in our nitrate issue. And then the other big component when you see Jocelyn's is a spike in the 2000s for the number of irrigation wells in the area. And if you're not familiar with economics of our crops in the 2000s, that's when we had record high corn prices, anywhere from $8 to $9 per bushel. And every farmer was ripping up every pasture possible to put a pivot on to raise corn because they were gonna make a bunch of money that way. Corn prices now today, if you guys would take a look, is right around $3 an acre. Not making a ton of money. Profit margins are very, very narrow. So with that, I'm going to show the research data results from the work that Dr. Iqbal did. He was the primary investigator on this along with 2 graduate students. But the big thing from his plots that he took out, which is important for us, is looking at that N calculator. So that tool that we're telling them to estimate how much nitrogen we're using for corn, when we talk to the producers and crop consultants, we have a third of the group that says, we're not applying enough nitrogen, we need to add more, that is wrong. We have another third of the group that says we're applying too much and that the algorithm is incorrect. And then we have the middle third that goes, it sounds good to me, I'm just gonna go with it. And so this was a prime opportunity to prove the logic and the economics of it. And so through this study, he looked at multiple different tools that you could do for nitrogen estimation, and then looking at that economics, and our N calculator from UNL falls in that realm, and it is showing that it is profitable to follow that for your operation. To give you an estimate, and once again, as I teach nitrogen certification, I tell every guy it's an estimate. Things change. We can't predict the weather. We can't predict. I was planning on putting 14 inches of water on this year, but we've had a ton of rain and I only put on 8 inches. I may have to put more nitrogen on. So we can make adjustments as needed, and as split applications, they have that opportunity. And then the second big point that Dr. Iqbal showed is looking at those enhanced fertilizers. So these are the urease inhibitors, the nitrogen inhibitors. What he was showing on these soils is they are a great option. He did have plots where they're putting all 200 pounds of nitrogen down for the year in one of these inhibitors, but we're not seeing an increase in nitrate movement. And the way he was able to tell if we had nitrate movement is there's lysimeters in each of the plots, and a student had to come up every single week to pull all of those lysimeters, and they're vacuum lysimeters, they were not the automated ones. And so we're actually able to see that water movement and that nitrate movement through the profile. So this is a great indication, where do we go with those inhibitors? But once again, then we can look at the counter part that Iowa is showing. Now we're seeing pollution of the inhibitor portion of the inhibitors in groundwater. So are we robbing Peter to pay Paul, or what are we doing? And then the last big one that is really critical for us is optimizing irrigation water. And with this, it was on a variable rate pivot. We had some plots where the producer was able to manage the water he normally does, and then Dr. Iqbal was managing the water. What we're really seeing is the producers are pushing the nitrogen through. And so irrigation management is probably the bigger key for us in the whole management process. Nitrogen is important, proper timing and placing is huge, but the water is probably our bigger player that we haven't been paying as much attention to. And so this is kind of changing our focus a little bit more on, let's talk about irrigation management, water holding capacity. How do we adjust to the weather when we can't predict? I'm gonna pick on like McCook, Nebraska, 2 nights ago had 10 inches of rain. But I just turned on the pivot and I just put an inch of water on, and I fertigated at the same time. You can't predict those, so how do we balance Mother Nature and our irrigation practices at the same time? The other great thing about the project is the research that is coming out of Nebraska Water Center. This next 2 slides, this data comes from Dr. Dan Snow from the Water Center. He has been doing a ton of beta zone sampling in the area. How long has he been doing beta zone sampling, you guys? 10 years?
Yeah.
At least 10 years. And so this is great data for us to go by. And if you don't know anything about beta zone data, really simple. What he's doing is he's pulling a core, a soil core from the surface until you hit groundwater. And then taking every 15 feet or whatever it is and looking at that nitrate load as we move through. He's coming back to the same fields after so many years. So we have multiple year data, which is really nice for us to go back. And it also helps us look at, okay, how well are the producers and the BMPs that we're doing working? Yes, we need to take Mother Nature into consideration, but it's helping us see, are our practices helping and working? And so what he ends up getting is this table, and all those little jaggedy lines, the little triangles, is the amount of nitrate that we're seeing per area, which you would kind of indicate per year. For a rough example. So this is one location in the Bazile. As you can see, we have 2 data points. We have 2023 and we have 2014. In 2014, we had 743 pounds of nitrogen still in that beta zone that still needed to hit the groundwater. That's a lot. So then we look at the maps that Jocelyn created. Why are we still going up? Well, we still have nitrogen in the soil profile that needs to make it there. But then we compared in 2023, 9 years later, we reduced that to 129 pounds per acre. Well, we can sit there and go, our BMPs are working. But there's another big piece that we have to take into consideration. We want to talk about, farmers want to talk about legacy nitrate, that this nitrogen is from great grandfather or from grandfather. But when we step back and really look at our soils, and Jocelyn showed you those connectivity reports, Dr. Snow did the exact same thing. This is one of the locations, and he was able to show that that nitrate is able to move 1.2 feet per day. What if my irrigation well is only 50 feet deep? So does that mean the nitrogen I'm applying this year, is it going into the groundwater this year? There's a possibility, depending on our irrigation and Mother Nature associated with it. There's a possibility. So is that legacy nitrate? No, it's not legacy nitrate anymore. It is us. And showing this type of data, especially at grower meetings, their eyes pop open. And their jaws hit the ground and they're like, no way. I'm still a player in this. I am still causing it, and it's caused some great grounds for communication and making them think about the whole process different. And that's where the research is really critical for us to get it down into a point that our producers can understand it. And it's this research is in their backyard, which is really critical in this area. The other big thing, working with extension and working as a university, I think most people understand this, we have to know what our impact, right, is. Are we making a difference? So I was working on a promotion file, and we all know how promotion files go. I have to show my own long-term impact. So we did a long-term assessment of everybody who has participated either on a webinar, field day, winter meeting, anything like that. And we got a 15% response rate, which is excellent. If you don't know, survey data, especially when it's by email, and I did not give out an Amazon gift card associated with it, it was all free will. But the great thing is it did show 63% are taking steps to mitigate nitrogen loss. Another 63 are adjusting their irrigation management to prevent nitrate leaching, and 50% have taken steps to reduce their nitrogen use. So it's just indicating our outreach is making a difference. Are we seeing the outcome that we want? Yes, it's taking us a little bit longer. It's not going to be solved overnight. So that is the research side. There is a ton of other research that is occurring where we're trying to do on-farm research. And that's what the new Bazile educator is going to focus more on, is getting producers to do on-farm strips so they can actually work on the projects and the technology on their own farm and see how it works. All right, any questions before I hand it over? Perfect, there you go, Connie.
And then we should just be able to turn this one on for you to walk. Okay. All right, so we have a problem. How are we gonna try to fix it? Part of the BGMA area, like us four are in, we decided we were going to make up a communication team. And we're the ones that, are the core of the team that help decide, we got a problem. Let's think outside the box. How can we help people? Well, nope. So we started with, okay, let's have a community work group. Yes, that's a great idea. We had our first meeting and COVID hit. What happened? Nobody was allowed to come to the meeting, so we're like, okay, that was a bust. Let's try something new. So we did several different adult educations. We've had winter meetings. They also get their nitrogen certification credits for coming to that. Field days, demo sites like Amy talked about. The nitrogen certification, Haskell lab, we had a booth at the lab day. The Women's Exceptional Conference, we had a booth there. We told the ladies, bring your water samples in, we'll test it right there at your sample at the table. And then we also offered or talked to them about the cost share for that. We had Congressman Adrian Smith come and we gave him a tour around the Creighton area. Another easy way that we've communicated with adults is social media, Facebook, Twitter, and our website. So feel free to check us out there. Then after thinking adult ways, we were kind of like coming to a dead end. We were like, what else can we do? So we came up with first annual Northeast Nebraska Ag Conference. So it was held at Northeast Community College. We had 15 different breakout sessions, and the breakout sessions focused on soil health and regenerative ag. We had a good attendance of 280 people. Very successful, and it was also free. We did plan our second annual one. It will be December 16th of this year. It will be back at the college. So if you're free, come check us out there. Okay, so we went adult. We're like, all right, what's something else we can do? Let's trigger the younger kids. So in March, we have H2O days, and we did the Skirt game there. And that's fifth graders. In May, we do activity with the Aqua Fest, also for fifth graders. May, we attend the Life on the Farm and partner with UNL Extension educators. And that, I believe, is fourth graders. And September, which was just yesterday, so if you notice, my papers are a little crinkly, it rained there, so my display got all wet. But it was a great, and that is freshman, sophomore kids. And also, we have the Know Your Well in some of the towns, working with the UNL Extension for that. In October, in Butte, we have our Conservation Day, so we're triggering eighth graders. And in 2024, we decided, what else can we do? You know, we all have a lot of downtime, so we thought, let's go into the classrooms. So we just worked with the area teacher that deals with science standards. And we made this flyer and we sent it out to all the schools in the BGMA area. And we said, these are the activities you can choose from. And the science standard and indicators are on there. So it goes from elementary to middle school and even high school. And we went into the classrooms and the teacher got to pick the activity that we presented on. And with all of them, we all tie to nitrates in the groundwater. How can you do your part? And so with one of the activities, we come up with, those that was on that list. One of the most popular ones is the soil Jenga, which is displayed over here. Nope. What? Nope. All right. No. All right. Okay. All right, so one of the other fun activities, and mind you, we do this with all age groups. We have kids doing this, we have even adults doing it. This picture here is at Haskell Lab. And we do have papers on this activities in the back if you want to grab it. But simple Jenga, we got the topsoil, when the air pours, organic matter. There you go, Vanna White. Topsoil. Organic matter. Green. Microorganisms. Water. Microbes are green. Water's blue. Nutrients and minerals. And groundwater. So we have a simple Jenga and we made it a soil profile. So how it works is the student or adult would pick one of these samples, pick any one of them. Do we want them to come up? I thought we'd explain them both and then you can choose which activity you want to come play.
And then you guys can come play.
So one of the activities here, and if it's a younger group, we make it a little more simple and just have them do one of the things. But this one I have in my hand is a cornfield was tilled twice prior to planting during the dry spring. Remove one topsoil. Remove one water. Remove two organic matters. And as you can see, that's why we make it a little bit simpler for the little kids. We just have them remove one. Hey, don't make it fall yet, Amy.
So usually we have two and we split them, we have two and we split them into teams. And the way who can keep their soils alive and up the longest? Dum, dum, dum.
And two air pores.
And two air pores. So here's the other trick, sorry. So this one is all removal. But do we do things that improve our soil health? So then we can put blocks back. And actually, that is harder to put blocks back than taking blocks out. But
So still standing.
So,
And plus, it's very inexpensive. I mean, a Jenga game, this you could even cut your own wood if you want to, and then just paint it.
so the question would be after this one, it was one practice. Did that really impact my whole soil profile? One thing. And especially the younger kids, you get into fourth, fifth, and sixth grade, they go, yeah, my dad does that. You mean to say he did that all to his soil by going over with the disc twice? Yeah, there's a good possibility. It may not be that extreme, but yeah, it's just another visual cue on what we do is impacting not just up here, but down here also.
All right, another popular game we play is nitrate movement kerplunk. And here we have simple practices, and these aren't all country practices, these are some town practices. And how I started is talking about different soils. Everybody has different soils, so I have my jars, I have sand, I have silt, I have clay, I have gravel. We talk about what type of soil would make nitrates go down into the groundwater the fastest. And how does nitrates affect us? So we talk about water and nitrates in the water. How is it healthy for you? How is it not healthy for you? How can you tell you have high nitrates? I got two samples here. Same I show my kids. Sample 1, sample 2. They look like water. They smell like water. They taste like water. How do I know which one has high nitrates? There is no way. The only way of testing it. So I test it with the kids. Little nitrate sampling test kit.
Here, how about we help you?
All right. So 1, 2. And then I talk about how you gotta put the lids on so you don't spill, because I'm very clumsy. And so then they have the chart on the nitrate test kit. So my sample 1, have them tell me how much it tested. You use the chart, it's about a 1. Is this safe to drink? Yes, and it's under 10 parts per million, it is safe to drink. But this beautiful, beautiful shade of pink, maybe it's not safe to drink, it's over 50 parts per million. Actually, that water is from our district, from one well, that's over 200 parts per million. So that's why I use it, because it changes really, really fast. Okay, so we have our water tested, and we talk about how you can't boil nitrates out, coliform. If it's high in bacteria, yes, you can boil it. High nitrates, you cannot boil it. Then I go into playing the game. They get to come up here. Oh, I talked about our maps. We already talked about them, so I'm not gonna go over them. And you can, when you get up here. And I talk about the health effects or health problems with high nitrate water, how it can cause cancers. Nebraska is number 2 in pediatric cancer. That is not something we want to be proud of. Talk about blue baby syndrome, about how the baby actually turns blue because the nitrates in the water takes the oxygen out. And we talk about my well being 200 parts per million, how that can even be too high and harmful for cattle. It can make them abort. For humans, if it's over 10 parts per million, it can even cause birth defects or miscarriages. All right, so we'll just grab one. I make the kid choose them, whichever one they want. Planting trees. Thank you, Vanna White. All right. Place 2 sticks back. Trees have extremely large root system and a long lifespan. The combination allows excess nitrates to be captured for several years. So then wherever they want, they can replace the sticks. And I guess I didn't talk about my simple little display. So my laundry basket is the groundwater. The dowels are my soil. So you can see the soils are all different, that's why I have different sizes of soil. My water molecules are the balls, and this color I specify as my nitrates. So our goal is to not get the nitrates down into my groundwater. And as the kids play it, they get silly. And then we kind of count a competition, which team has the most nitrates that drop. So both of our displays are quick, easy games, not expensive.
No, and it's just chicken wire. Holding it all together.
So if you guys wanna come up, I think that was in my last.
We would love for you guys to come play.
So if you wanna choose one, oh, and the papers are back there if you wanna take one home of the two games, but come on up, play, or if you have any questions.
I'm curious, what is the relationship like between the farmers and the public drinking water systems?
You wanna answer that? Or you want me to answer it?
Yeah, that's a tricky question. So we get a lot of arguments from the producers, blaming people in town, lawns and golf courses, because they're also applying nitrogen on their grass. And then you get people in town blaming the farmers because it's a lot larger scale, so. I mean, it's not like a hostile situation by any means, but yes, I mean, it becomes a big blame game between the two. I think my answer would be it's probably both. And then you also get the producers blaming the cattle guys too, so. I think it's everything, so yeah, it can be a tricky situation. In these small towns, most of the people that live in town are also producers themselves. So it's a little bit different there, but,
That was one of our goals of the community action that we started in sorry. That was one of the goals of the community action when we started in 2000 to bring all the players together. And say, we all play a part and we all make a difference in making these changes. But as Connie said, COVID happened. You can't do community action teams on Zoom. We tried, it fails miserably. And we just haven't gone. We kind of felt beat down and we haven't gotten ourselves picked back up to try to do it again. Cause it's, I mean, Mark's in the room, it's easy for me to look at Mark, it's a lot of work. A lot of work to do those type of things, but long term, it probably has the best action, but we're gonna get there eventually. 11:53.